Alright, so this is going to be part 1 of arc length problems with parametric equations. Alright, if you didn't see the explanation video where I actually got this arc length equation and then we did a little quick example, definitely go check that out. Alright, so we have our problem up on the board here. We need to find the arc length of x equals 1 plus 3t squared, y equals 4 plus 2t cubed from 0 to 1. Okay, so not anything too crazy here, alright? We need to find dx dt and dy dt, alright? And we already have our bounds, that's 0 to 1, right? We're given that in the problem. So, we can find dx dt, right? That's just taking the derivative of this x equation here. And that's going to give us 6t. And taking the derivative of the y equation here, we're just going to get, well, this will be 6t squared. Alright, now we have everything that we need to actually plug in this equation here. So we get the arc length equals the integral from 0 to 1 of the square root of 6t squared plus 6t squared squared dt. Alright, now doing our exponents here, we're going to get 36t squared plus 36t to the 4th dt. We can just take that 36 out of the radical here to get 6 the integral from 0 to 1 of the square root of t squared plus t to the 4th dt. We can also take a t out, or well, yeah, we can take a t squared out of here, which will be a t on the outside. Guess I could have done that with the 6, but 6 the integral from 0 to 1 of t, the square root of 1 plus t squared dt. Alright, cool. Now what do I need to do? Well, this is just a simple u substitution, right? So let's do a u substitution. We get that u is going to be equal to, well, 1 plus t squared. And du is equal to 2t dt. We can divide by 2 on both sides if you'd like to get du over 2 equals t dt. Oops. There we go. Alright, so we're substituting with that and we're substituting with this. So we can, oh actually, we need to also change our bounds. Forgot that. Alright, so when t equals 0, what does u equal? Well, u would equal 1, and when t equals 1, u will equal 2. So now, we also have bounds. Alright, now, this is going to be that the length equals 3 now, alright, because remember du over 2. 3 the integral from 1 to 2, those are our new bounds of, this will just be u to the 1/2 du. Alright, and we take our integral here, the arc length equals 3 times 2/3 u to the 3/2 evaluated from 1 to 2. And doing that evaluation here, we get that this is going to be 2 times u to the 3/2 evaluated from 1 to 2. Well, that's just going to be 2 rad 2 minus 1 rad 1, which is 2 rad 2 minus 1. And if you want, you can distribute that 2 here to get 4 rad 2 minus 2. If that's your answer. Alright, so pretty straightforward here, right? Just a simple u substitution at the end here, but really, find dx dt, find dy dt, use your interval as your bounds, and you'll be set. Alright, so that's going to do it for this video.
So if this video helped you, make sure to leave a like and subscribe by clicking my icon in the top left. You can also view the playlist for parametric and polar, the explanation video for arc length with parametric equations, and the next video in the series. See you soon.